Okay, am I hot? Well, no, that's the wrong question, isn't it? Is my mic hot? Yeah, I guess it is. Welcome, folks. You're probably a little bit tired of looking at code and things like that. Let's use the other side of your brain a little bit in this session. For those of you who don't know me, I started writing code in the 1970s, if you can believe that, before many of you were born. And I have a lifelong interest in science, going all the way back to as a kid and through present day. And about 12 years ago, I started doing a lot more work in UX design. I still code, but I actually design software more than I write code these days. Now, I look at design through the lens of science because of my experience, and I find that most designers don't really look at it that way. Most designers have an intuitive approach to design. And see, I know developers. You don't go for that touchy-feely intuitive stuff, do you? No. You have to have reasons for things. And the reasons are typically based in the science of the visual and cognitive systems that all human beings share. And this session is about that science and explaining some of the design principles that come out of that, some of the mistakes that developers sometimes make, ways to avoid those mistakes, better options. So I hope you'll enjoy this session as a little bit of a counterpoint to some of the other things that you've seen. One of the reasons this is important is that people's expectations are rising. I was at the reconstructed Globe Theater yesterday, called an Uber to take me back to my hotel. Beautiful piece of software. Most of the value of the company Uber is in that app right there. And because of experience with things like that, people's expectations have gone up. How many of you have a screen that looks more or less like this somewhere in your app today? Yeah, see. And this isn't good enough anymore. And so to do better, you need to understand what your users see. That's the foundation of giving them better design. You can talk about A/B testing, but why is A better than B? Why did they prefer B over A in some circumstances? Is there a C out there that's better? Well, design principles inform us on that, and you can get better designs faster if you understand some of those principles. Now, I'm going to bring the next thing up, but first I need to ask a question to see whether I need to actually show this 30-second video. How many of you have seen a video where there are two teams passing basketballs around? How many of you have not seen that video? Oh gosh, that's the overwhelming majority. Would those who have seen it indulge me a little bit? Yeah, but you must be quiet and not give away the answer to the question that I'm going to ask them, okay? So let's show that video then. Let's with this. I've got it, I think, right here. I do. Okay, let's make this full screen and play.
Blindness test. How many passes does the team in white make? Go!
How many passes did you see? 13? There's a little bit of ambiguity, but most people see 13. Now, for those of you who have never seen this video, my next question is actually the most important. Was there anything in that video that you saw that was unexpected, that didn't seem to be in place with the rest of the video? Anybody? Yeah. A monkey walked across? Who saw a monkey? A few. Who saw nothing like that whatsoever? Well, it wasn't really a monkey, but let's play the rest of it.
The answer is 13. But did you see the moonwalking bear? Go!
I've been in groups of developers. I've been showing that video for a long time. I was at Micron Technologies, if you know them. 15 people in the room, not a single one saw the moonwalking bear. So if you didn't see it, don't feel as though you are defective in some way. It has to do with the way your visual system works. And I'm going to explain a little bit about that. But first, I'll give you another quick test. Now you know that you're supposed to be looking more attentively, and yet you'll still struggle. In this test, I'm going to show 3 slides with drawings of household tools that you might find in your house or workshop. I would like you to tell me how many of those slides contain a hammer. I'm only going to leave the slides up for a couple, 3 seconds each. Are you ready? How many hammers? 2. Most people see 2 hammers without too much trouble. But then, how many pairs of pliers? How many pairs of scissors? How many wrenches? You see, you think you see all of the screens that you look at, and you think your users do too, but they don't really. The human visual system simply does not work that way. You only have a small portion of high resolution. The part of the retina that gives you that is called the fovea. If you want to see the amount of high resolution that you have, hold a pound coin out at arm's length, and that's the approximate amount of high resolution you have. A design principle is something that describes how users interact with designed things, including computer software, based on the way their brains and visual systems work. You can't just train people out of it. It's a part of our biology. And that inattentional blindness is one of the design principles. We're going to look at several. Gestalt principles are up next. We're going to look at color and hue, how we perceive that to signal information. We're going to look at other experience-based visual things, such as archetypes and familiarity that combine visual and cognition. But inattentional blindness is the first one because I demonstrated to you that it exists in you. And that's a way of helping you understand it exists in just about everybody. So one of the things that means is your eyes are constantly darting around to pick out the part of the visual field that's important right now. And as you saw, that tendency is based on what you're trying to do, the task at hand, and what you expect to see. You expected to see hammers, you found them. You didn't expect to see scissors, so you filtered them right out. You didn't expect to see a moonwalking bear, you filtered it right out. That's the way the visual system works, and that's one of the reasons, for example, that we don't want crowded screens. Let's go back to this. I showed this a few moments ago as an example of the kind of screens that exist in many apps today. Let me black it out. There was some demographic information in the upper left. How many of you noticed who it was for? Sherlock Holmes. I didn't give you any priming, so you didn't really look at that screen, did you? Only a few people happened to notice that. Well, in fact, even if you look for something in particular, what you really get, this is a simulation, that the part that you're looking at, the fovea, zeroes in on a small part of the screen that you're looking at. The rest of it, you don't really see it. And I've simulated that with some blur here. And that means that you didn't notice something about that particular screen that I'm going to show you now. By the way, I have several demos here. They are written in WPF for desktop. So if you are interested in that technology and you'd like to get these demonstrations, I'm happy to give them to you. Billy, did you think, I think I need to start this over. I was fooling around doing something. Okay, so here is that screen, and I've made it so that I can drag this thing around. And again, that's about the area you actually see closely. What you probably did not notice is that the further to the right you get, the more this screen turns into complete gibberish. Did anybody notice that as you were looking at it? All right, let's take a look and see. For example, if you start to move over to here, what's a fustimate? What's a frenulum? Blastokink. Fisher table, that almost sounds reasonable. What's a dingleplop? What about a raster possum? You see, you didn't really see those things. So when your users tell you they want crowded screens, no, they really don't. What they want are well-designed screens that give them access to the information they need. When they have a crowded screen, if they don't need some of the things that are on there, they just filter it out. In fact, it kind of makes it more difficult for the fovea to zero in on what they need. A screen that's looser, more white space, with groups of things they might be interested in, will work cognitively and visually far better. So why do users beg for crowded screens if you are convinced by what I just said? Well, that's because they don't trust you. They assume if you don't put the information on the first screen they see, that you will hide it somewhere and they'll never find it. And they assume that because they've had experience with people doing just that to them, developers that don't understand their job and don't understand what pieces of information they really need to see. So it's a much higher level of responsibility to give them an uncrowded screen. It means you have to understand their job and more about how they use information. But the result is vastly improved productivity, lower training, and things like that. And the patterns for dealing with too much information are well established. You've got one of them on your smartphone right now. You look at the settings app for a typical phone. This is for iPhone. And first of all, information is categorized in some kind of hierarchy to make it easier to find. But that simply doesn't work in all cases, does it? Especially when you start running into hundreds of different things people might do or hundreds of pieces of information. So what do they do about that? They put a search capability to zero in on the things that people are interested in. That's one of several patterns for dealing with lots of information. You should understand those patterns and be able to give your user screens that aren't nearly so crowded. So now we know what the fovea looks at. What's the rest of the vision for? Well, peripheral vision really doesn't do that much for you in software. In the real world, it does. It alerts you to dangers and things. We see a little bit of that in software when we jiggle an error message or something, because movement in the periphery draws people's attention to it. So we can get their attention by vibrating something a little bit, animating it. Don't do that too much. It gets to be annoying. Do it just a little bit and then stop. As you saw, what users see is heavily influenced by what they expect to see. Let me give you an example from my own personal experience in real life. And by the way, I often do real-life examples to drive the point home because design is everywhere. And the principles in the real world apply to your software in most cases too. So let's ask a question to start with. First of all, I'm going to the ground floor elevator in a parking garage. How many elevator buttons do I expect to see? Just one? Going up? I can't go down. There's no down. Okay? What is the shape of a typical elevator button? Round. By far the most common. So I walk into this parking garage toward the elevator, and this is what I see. I see a round thing that looks like a button, and I walk right up to it and press it. And then the guy comes on and says, yes, this is security. Because I'm thinking about other things, you see. And my eyes just see that little thing and just filters out that stuff on the side over there, because that's what I pressed. And he was used to this. People must do this a dozen times a day. He sounded bored. He certainly didn't think it was an emergency that I'd press the call button. And you look over to the full picture and you see that there is the elevator button. It doesn't really stand out or anything. So I pressed the wrong one. That is unambiguous evidence of bad design, and it illustrates some of these design principles. For example, we're going to talk a little bit about archetypes later. An archetype is an expected form. The most common elevator buttons that you see are round. That's an example of an archetype. This could be fixed in a number of ways. They could color this thing red. I don't expect elevator buttons I press to be red. They could put a little flap over it so that I had to lift the flap to press it. I don't expect elevator buttons to have flaps. That would have jerked my mind back to, oh, this is not an elevator button, and I would have looked and found the one to the side of it. Other examples of expectation, setting how people see things. There's a concept called framing. They've done research on this. They led people through a series of models of kitchens, and they pretended it was some kind of marketing research. They did about 10 of them. In 2 of the kitchens, they left out the stove. When people got to the end and they were asked, almost everyone assured the researchers that they saw a stove in every kitchen. They filled in the stove that wasn't there because that was what they expected a kitchen to be like. They expected a kitchen to have a stove in it. So people's visual perception is extremely sensitive to what they expect, even to the point that they will imagine things that aren't even there if they expect them to be there. People's perceptions and actions are also subject to something called habituation. They get in the groove, in the habit of doing something. Let me show you a spoofed up software example I have for that. Let's see, where is it? Oh, yeah. It's another one of these. Yeah. Is it that one? Oh, wait. Where did I put the example for that? There it is. I haven't quite moved all my examples into that one central place yet, but I am going to do that. So imagine you're in this typical situation of you're leading your users through some steps. And you get down and you get ready to do some things, you press the next button and you go over to the next screen. Do some things, press the next button. Do some things, press the next button. Do some things, press the button. You just click the back button, you see. Because the person designing the screens, me, stupidly or viciously changed the back and next buttons. And you think, no developer would ever do that. That's stupid. I give you American Airlines. This was a screen I captured trying to get a flight. Oh, it's been about 3 years now, I think. This example of doing things, this way of doing things, was up there for 18 months because I looked to see. Let me set it for you. This is the 4th screen. You've bought a flight online. You know what the story is. You pick your date, you do this, you do that, you fill in your name, all the bureaucratic stuff. This is the 4th screen, and every other screen has had a button in the lower right-hand corner, which was basically the continue button. So I finished filling out this screen, scroll to the bottom, and press the button in the lower right, and I don't even read it, because what do I expect there to be? That's the continue, right? Well, here's what really happens is, if you don't fill in the credit card information, then it doesn't show you a continue button. They decided that buttons that you couldn't press should not be shown, which seems reasonable. And then they decided, well, our buttons, for cosmetic effect, are going to be right aligned. Those two things sound completely reasonable until you put them together. And then you get this. So that once I filled in all the credit card information, it changed to this. American Airlines was losing money every day their app worked this way. Because some percentage of people would hit that start over button and go, well, screw this, I'm going to Delta. Going to British Airways, somebody. I actually flew over on British Airways from Nashville. They have a direct flight here now. So understand that part of the problem with that was the expectation of where the button was. But also part of the problem was that shape and color signal better than text. I didn't even bother to read the start over. Reading takes effort. It takes a lot more cognitive effort than seeing shapes and colors. And your users, in many cases, probably are not as fast a reader as you are. And they don't understand a lot of the words you use. It's just jargon to them. So let's see an example here. This is the sort of screen that I've fudged up, but is, I hope, an example of the kind of thing you might put up to alert somebody to a security condition. This sounds perfectly reasonable to you, but this is how your users perceive it. They don't know the words. All they know is you put up a step that keeps them from doing what it is they want to do. And if you say clicking this will let you do what you want, then they're going to click it. The rest of it is irrelevant to them. So don't put up a lot of text like that. Instead, use color and shape to put meaning into your apps. This is an app we did for a company in Minnesota in the USA. They have a package that helps manage propane distribution. Well, if you're in the propane business, these two tanks make perfect sense to you based on your experience. A propane tank is kind of Tylenol-shaped, capsule-shaped, and the color of propane is light green. Fuel oil, kerosene tanks, have a different shape, more like an elongated cylinder, and their fuel is red. So you need no training or anything to understand what the type of the tank here is and how full it is, because we've given that visualization to you. You instantly know the information, the critical information you need to know about that particular customer's particular tank, because some people have more than one. Let's do a little test here. Let's look at the third one over there, and you see there's like little circles emitting from the top of it. What do you suppose that means? Come on, you're smart people. Somebody will get it. It's a wireless gauge. So that tank is equipped with a means to constantly transmit how much fuel that it's got in it. And that's a much better way of doing it than putting some checkbox that says, has wireless gauge, checked or unchecked, which is what, unfortunately, quite a lot of developers would do today, probably in a cell of a data grid. Because the most common design I see in apps today is what's normally called the wall of data grids design. And as you move forward, people's expectations get better. You need to be able to do better with things like this. Also notice some of the use of shape along the bottom down there. That's the most recent interactions with that customer. Now, an interaction with a customer might be several things. It might be a service call, it might be a delivery, it might be payment of a bill. Which one on the bottom do you suppose denotes a service call? I'm sorry? The first one? How could you know that? I haven't trained you on this app. Because in the background is a wrench, and it's dim enough that it doesn't interfere with reading the text at all, but it is perceptible enough to guide the eye to the thing that somebody's looking for. So using shape and color can be powerful indicators. There are some others on here, by the way. There's a smiley face in the upper left, says this is a good customer, or I'm sorry, a happy customer. And then there's a COD over on the left, that's America. In America, that means collect on delivery. Is that the same phrase used here? And it's red because you want to know if somebody doesn't pay their bills. I guess they're happy because they haven't had to pay for their gas. The visual system is also very influenced by context. For example, I'm going to show you a slide, and I'm going to prime you for it by telling you that it's a campus map, and you'll see roads and buildings. You ready? Okay, so you see roads and buildings. But now what if I tell you there's a word in the buildings? Did you feel your visual system shift based on what you were looking for and expecting? That's an example of a principle called Figureground. You've probably seen this famous diagram right here. What do you see? Two faces, a vase. And now that you know that they're both there, you can switch between them. That, again, is an attribute of the way the visual system works. It decides that certain portions of the visual field are important and others are not important. And it focuses in on the part that it considers important, the foreground, and then filters out the rest, the ground or background. And you go, what does this have to do with software? Well, and one of our first modern apps that we wrote back in 2008 had a data entry screen that looked like this. And you can see that it's kind of called out subtly against the background of the shell in which it sits. But now if you want to do an address, that's an overlay. That's a pop-up. So that looks like this. And we animated it actually so that I don't know if you noticed, what was previously the ground right here shrinks when you go to here. And we animated that, and it has a gray cast over it. You can't click on it either. So now we have told the visual system, you have a new foreground that you need to focus on. But we've preserved the context. Here's where you were, and here's where you're going back to. So we keep the context, but we guide the user's attention into the thing they need to work on. And actually, this became a fairly popular way of doing things on the web for a while. Some places still do it. When I first did this presentation about a year ago, Twitter was doing this with a little bit darker background than ours. However, just knowing that a design principle exists doesn't necessarily mean you understand how to use it right. Let me give you a great example that a lot of you probably experienced. How many of you used Visual Studio 2012 at some point? Yeah, you remember the famous toolbar up at the top? It had no color whatsoever on it. Why did they do that? Well, first of all, understand that, like most of the community, people at Microsoft are very, very code-centric. They think in terms of code. So they said, well, Figureground, we need to draw people's attention to the most important part. And to them, what's the most important part? Code. So the code window became the foreground. And they said, we'll just de-emphasize everything else to make it really easy to use the code window. The problem they didn't understand is that what you need to be interested in shifts. It's not static. You saw the example I just had where the foreground needed to shift to a different view. If they'd made it so that when you put the mouse over it, it lit up, then that thing would have been fine. But as it is, I was doing a session about 6 months after this was released, and I did the uncomment button. And one guy in the audience said, I've been looking for that button for 6 months. It was that hard to see it. And of course, they've changed it since then. The bottom is the more recent version. I think that's 2017. By the way, I still think this could be dramatically improved, but it's not as bad as it was. You can also be primed by past experience. As you saw, the elevator example was a good example of that. I'm going to show you another elevator example, and I want you to take a look at it with the following in mind to see if there's anything about this elevator panel that you find worth calling out to someone if you got on the elevator. Just look at something, and when you have something, put your hand up so that I'll see when most of the audience has found something. By the way, there are multiple things you might find, and then I'm going to talk about the one that I found and why. You ready? Okay, what do you see here that you might mention to a companion when you got on the elevator? Now, don't say it, don't say it. Just put your hand up when you have something. Come on, I'll get a few more. That's not too bad. What did you see? There is no number 13. How many of you saw that as the first thing you noticed? Yes, because, see, you're developers. You have that analytical portion of your brain working 8 hours a day in your office or cubicle, so immediately you looked at this and went, there is a missing number in the sequence between 12 and 14. Okay, but that's not why I took this picture. It is true. What else did you see?
All the labels look like buttons.
The labels look like buttons. The placards look like buttons. And we know that that's a problem because of this. That's what I saw and got my camera. Now, by the way, this is a train wreck of bad design, so I'm not going to go into deep analysis of all the things that are wrong, but that's the first thing I noticed. Unambiguous evidence of bad design, because people are getting on the elevator, seeing that placard, thinking it's a button, and hurting their finger pressing it many times a day. And think about this, when they do that, they've already been up to their room once. They're now on the elevator for at least the second time. And they're still making the mistake. We're going to come back to this elevator panel and point out another problem in a few minutes, but that is an example of you see what you're looking for, and remember that these principles kind of work in concert. Why don't I see the button right next to the G? Well, we saw that, didn't we? That's the way our visual system works. It sees small chunks at a time. By the way, this is not the only elevator to exhibit this problem. I've made a hobby of collecting them. This one's in Las Vegas, and at a very upscale hotel, by the way. And I got on it, and the guy standing by the panel said, what floor are you on? I said, 25. And he pressed the button for 24. And he said, oh, I'm sorry. I said, don't worry about it. Let me explain to you the design of elevator paths. No, you want things to be clear. You want things to stand out in such a way that people won't have any trouble. Notice, for example, this is another example of the fuel tanks. When they get low, we put 0%. We make that big. But notice that there's still a little bit of propane in the tank, so to speak. Now, see, my naive point of view when I wrote this control for the client was when it was 0, there was nothing. But your experience in that industry tells you, no, that tank's never really empty. It gets so low that it can't get propane through, but there's still some propane in the bottom of the tank. So our visualization reflected that. Yeah, I think I did what I was going to do here a few moments ago, so I'm going to go on. Other ways that design principles affect the way you and your users see things, including computer screens. Let me show you a sign in a hotel in Texas. I got out the elevator about 11 o'clock one night, and I was tired, bags, etc. And I see this sign. I'm in room 207, so I see that, and I trot off to the left. Get 2 doors down and realize I'm going the wrong way. Go back and look at the entire sign, which looks like this. Now, when I took this picture and put it in my presentation the next day, my design training, one of the people in the audience who'd come in from out of town said, I did exactly the same thing. Why were we both misled? Well, the problem here is that our mind, our visual system, automatically groups things based on how close they are to each other. That's called the Gestalt proximity principle. So if I look at 201 to 223, that's the range of my room, which one of the arrows is closest to it? The one below. This sign could be vastly improved by doing nothing more than moving the arrows down about 2 inches, 5 centimeters each. And you think, oh, well, software people don't do silly things like that. I give you Amazon, in which I am on their specials of the day page one day, a few years back, and I see this 128 gigabyte USB. Man, that's, I'm on the road a lot. That sounds great to me. Only $29.99, good price at the time. So I check the box below it and then hit the thing to put things in the shopping cart, go over to the shopping cart, and that's not there, but there's a random item that is, that I didn't think I picked. Have you spotted what the problem is? The upper checkbox is for this, but there's no real visual indication of that, and it's further away from the item than this is away from the text. So it was a natural mistake. Again, they're losing money every time they do that. Gestalt principles were studied by German scientists about a century ago, and they looked into how the human visual system tries to see the world in terms of structure and relationships. So there are several principles of design that come from that, called Gestalt principles, and one of them is proximity, as you just saw. And the reason that they work the way they do is that the human visual system actually goes through several stages in perceiving something. The first stage happens in the retina itself. The retina is optimized to boost certain signals like edges and dampen others. So there's one stage of visual processing that goes on the retina. You can't really do anything about that one. It's just automatic. Stage 2 is automatic too. It turns out that we can do some alteration, but the first cut of what you see is in what's called pre-attentive processing, small fraction of a second, and that is unconscious. At that point, you assemble the things in your visual field into shapes and groups. So when I saw that sign, I assembled the group of this is my room range and this is the arrow. My eyes did that automatically. And then in attentive processing, we use experience to layer on top of that to maybe alter the results of stage 2. We know what it is, or we realize that we didn't, that we were wrong about our interpretation, so we go back and use cognitive effort to reinterpret. You see that sign from my hotel room? I figured it out. So in that respect, the sign maker probably thought he did his job. But I had to expend additional cognitive effort to do it at a time that I was tired. And if you do that consistently with your software, you'll end up with some very frustrated and unproductive users. Gestalt principles do come from that stage 2, and it's unconscious with the ability to override it if you need to. Let's take a look at Gestalt proximity in a little bit more detail. First of all, if you put things together that aren't appropriate in some fashion, there are problems with that because people have to, number one, reinterpret the results, but number two, if you put something too close to something else, then that raises the risk of picking the wrong thing by mistake. I was working with a piece of software, a product that had the equivalent of code behind, and this is the button by which you would go edit the code behind. A lot of code behind was automatically generated for you. What this button did was wipe out your code behind without giving you any sort of warning it was going to do that. All right, that's bad design number one. You shouldn't have a button that throws away hours of work without telling you. But secondly, notice how close it is to the edit button. I didn't mean to hit it. I was just in a hurry and went for the edit button and just happened to be a little bit too far to the right. So proximity also helps prevent errors. The iconography is awful too. What about that chain link says, I'm going to delete your code? And back to the elevator again. One of the things that's wrong there is that the proximity principle is not respected. One of the reasons you have trouble finding which floor that a button goes to is that buttons are equidistant between two placards. You have to look at the entire row to figure out what button goes with what placard. And again, that's possible, but it requires extra cognitive effort. So, for example, those buttons have Braille on them, by the way. I'm not sure how much good it does. Because if you're a blind person, you get on there, you find 4. Well, which button do you press? How do you know when to get off? Now remember, this works inside your mind. You don't exactly control it because it's pre-conscious. Let me show you. I'm going to show you a couple of slides that have 4 pointed stars on them. And I want you to immediately perceive whether you see rows of stars or columns of stars. And just yell the answer out when you see it, okay? Rows or columns? Everybody saw rows there. Rows or columns? Almost everybody sees columns here. Well, that's really interesting because in essence, those two are the same size grid of stars, except for the fact that they're grouped differently. There's padding between elements that helps promote Gestalt proximity, so our eyes automatically group things because of the spacing. Do you see rows or columns in this one? A little more ambiguous, but most people see rows, and you just saw columns on it now. But what that says is that the mind also groups things by other attributes, including color and things like that. Color, shape, and size are the big things. Color and shape more so than size. Size is a weak sort of grouping attribute, so that we can group by color like this. We'll see rows. We can group by shape. Most people see rows there too. And those principles, by the way, have been used in things like charting software all the time. Proximity draws together a particular period, but similarity by color helps us follow a category over time. So Gestalt principles in use. If you violate Gestalt principles, you can help make things stand out very quickly. So for example, you don't have to search. If I tell you to find the triangle on the next slide, you don't have to scan around for it. Your visual system finds it automatically. And if I tell you to find the green pointed star, same thing. Your visual system zeroes in on it very quickly. And we can use these kinds of capabilities to help people find the thing they're looking for. Let me show you another one of my little sample programs. Okay, so here's a bunch of letters. Suppose I tell you, find the Z in this bunch of letters. Well, you kind of have to scan around a whole bunch, don't you? Has anybody found it yet? But if I make it bold, how much easier is it to find it? Much, much easier. How about the B? Have you found the B here? Well, it might help if I would shift it over a little bit from all the others. Those are the kinds of signals that our visual system is tuned to pick up, to pick out something that's of interest. And we don't use those kinds of signals in software very often, as far as I can see. In particular, shifting something over to draw attention to it, I see it in some well-designed apps, but I rarely see it in routine business apps. I'm going to show an example later of where we used it for one of our clients. Come here. Proximity can also be misused, or bad signaling about proximity causes confusion. When I had an Android phone, this was the Southwest app, and I'm on the boarding pass, and I see the thing up at the top, and GPay, I don't want to pay for anything. I've already bought my ticket. Do you understand what it's trying to do? It wants to put the image in the wallet, but it's not being clear about that. And furthermore, and save to phone. Okay, yeah, but is that one button or is that two buttons? That divider in the middle makes that distinctly ambiguous. Don't do things like that to confuse your users. Gestalt continuity says that people tend to follow something, a consistent structure, until something interrupts it. So you can lead people's attention to things using Gestalt continuity, or you can make something stand out by violating it. Here, for example, is supposed to be the timeline of a truck driver doing things. And it's spoofed data. I mean, nobody takes 3-hour lunches in that business. But notice that there's one of his daily tasks or appointments that's off from the others. What do you suppose that offset means? I'm sorry? Collision, yes. It overlaps with another thing that he has to do. So that was a very convenient way to very quickly signal that. And that's an example of something that, number one, isn't too hard to figure out. And number two, is a very sticky design. Once you've figured it out, you're never going to forget it. You'll scan and realize that you've got something offset, and therefore that you are double booked. Let's go through another example that combines a lot of these things and introduces a few new ones. I'm going to put up a set of data records, cards, for sports equipment. And what I want you to do is count the number of American football items that you see. I mean, I know you guys don't use those here, but you know what they look like, right? The oval things. All right. Okay, how many American footballs? 3. There were 3. Must have missed one. Okay, but notice that you had to do quite a bit of scanning around to find that. And as before, of course, you don't know how many basketballs there were, or soccer balls, because your eyes filtered those out. And I don't need to discuss that in detail. That's just another example of an intentional blindness. So how do we get around this? How do we make things easier for people to see and understand? Well, one of the principles I haven't talked about yet is mapping, and I'm going to get to a couple of other examples later. Mapping, that design principle, refers to matching things on a computer interface or some other interface to the real world object that is being affected, something about the real world. Because people intuitively then will understand the interface based on their experience in the real world. It will make it better. For example, we could make the pieces of sports equipment to have sizes that correspond to their real world sizes. You see, this doesn't do that, does it? A baseball is the same size as a basketball. That cognitively kind of makes it difficult. It's one of the reasons this thing was hard to interpret, even just to find footballs. So why don't we make the items mapped in some fashion? Their size on the screen should be associated in some fashion with their size in the real world. Now, tennis balls and baseballs are smaller and much easier to pick out. Soccer balls are somewhat smaller than basketballs. And we can leverage a lot of design principles to make displays like this better. Mapping was just one example I picked out. We already know, for example, things close together are visually grouped. We know that color helps in grouping. Well, let's put that together and see what we get. Suppose we get something like this. Now, how much easier is that to interpret than the first thing that you saw? Now, I don't have to work very hard to 3 footballs, man. How hard could that be? And by the way, this isn't made to have beautiful aesthetics or whatever. This is a fudged example simply to illustrate principles. So there are various principles being used here. We're using size, shape, color, and proximity all to do groups. That's 4 of the Gestalt principles, all wrapped up in one example. We also should call out information importance more than we do. And we could have done this back in the 90s. And I saw we had a font size for Visual Basic back then and its competitors. But we just didn't do it very often because we weren't tuned into the fact that different size can signal importance of information. At the time, a lot of us were coming out of character-based applications where we couldn't change the size. All we could do was affect boldness. But color makes information stand out as well as being bigger. Red family colors, of course, extra importance or danger or something. Green and blue are more safety and normal. So back to this screen, and we see the red calls out the COD up there, and the green up there tells us that we're okay. So let's see what I want to do. Yeah, I'm going to get through that. Now, the information importance. Yeah, if you look across the top there, you'll see some of the most important things about this customer. You can imagine someone picking up a telephone in a propane shop, talking to someone on the phone. What do you want to know about them? Well, how much money do they owe me? When's the last time I talked to them? How much gas do they have? Those are the kinds of information that we'd be interested in the moment we find out who that person is and call them up on our screen. We'd probably also want to know what are the last few interactions that we've had with them. So we make things bigger to call them out, and we use symbology to call out the different types of things that we do. I talked about that before, but that is an example of using these various things to emphasize the importance of information. And this really isn't that hard to do. You can see here red and green signaling. We've got some red and green signaling up there. I hate the yellow dashed line, and I can't convince the client to remove it or to change it. But the rest of this I'm pretty much okay with. We notice the positioning up there. The high priority items are lifted up a little bit. The ones that aren't so important have neutral backgrounds. So all of those things, color and size, are very useful in helping people see the information they need very quickly because they're leveraging what's going on in the visual system. It doesn't require cognitive effort. You put a data grid in somebody, they have to interpret a lot of text and numbers. They have to use more cognitive effort to get the information out of the grid that they're looking for, whereas if you visualize it in such a way that they can leverage the visual system is like the brain's GPU in a sense. It's optimized for something different than the cognitive reading portion, and it's more efficient because it has a much longer evolutionary history. Visual systems go back to our mammalian ancestors and even before, whereas how many species know how to read? That's a comparatively recent evolutionary development. We've seen that users are primed by goals. Usually when they go to your software, they've got some goal in mind. And they look for things related to the goal and filter everything else out. So you should understand their goal. Make it easy to to find the things they want to do that are related to that goal, get the information that they need. That means before you design a view in any technology at all, you should understand what are the 2 or 3 most common actions they take on that view. You should know their job well enough to know that. And you should know the 4, 5, 6 most important pieces of information they need to accomplish their goal. Now, this is loose. Sometimes it's only 1 action, sometimes it's 4, but 2 to 3 is typical. 4 to 6 is typical for the most important pieces of information. It could be a little less or it could be more. If you know those things, you're ready to design that view much more effectively than if you don't. If you just dump everything on there, if you don't really understand what's important and what's not, well, no wonder you don't use size to call out what's important. You don't know what it is. So find out what it is before you get ready to design a view, and go back and talk to users if you need to about what they need. Now, these principles can unfortunately be subverted. This is a concept called evil by design, to induce the users to do things that you want them to do, but are not necessarily in their best interest, and it's highly unethical. An example is here from the Hilton Honors app for Android. When I went to install this on my Nokia phone, this came up, that their frequent stay app wants access to my contacts. Why? They don't have any reason to want to talk to my contacts, and that's a potential security breach for their customers. They should never have done it. For the record, by the way, I've corresponded with them about this, and they just don't care. I mean, I can show you the Twitter stuff back and forth if you want the details. And notice that the stuff having to do with permissions that you're giving them is kind of gray background, not particularly bright or bold or easy. You won't notice it. They don't want you to notice it. What they want you to do is click this big green install button down here, and to make it big and green and make it stand out, to influence you to do what they want. Don't do that sort of thing. It's unethical. By the way, they even changed it. They made it even worse. Now, that was the way it was when I first went in. Nowadays, when you go in, they don't even show the security stuff unless you press a button. I forget where the button is on here, somewhere. And the permissions, view details, there it is. When you do that, you get this. You get that same stuff. But now they hide it 1 layer deeper. They're progressively becoming more evil in their UX design. I don't stay in that hotel chain, by the way, because of this. Citibank really wants me to go paperless, but I'm paranoid. I don't open my paper statements, but I do throw them in a box. And there have been a few times in my life where I was really glad that I had those paper statements in a box. So I'm not going paperless. I know they want me to. So they put this thing up, make all of your accounts paperless. And now they've got accept and manage settings. What does that mean? Is that going to lead me down the same path, that there's no exit back to unpaperless? I don't know. What I want to do is go to my accounts. Where's the button for that? Well, it's up there on the city icon. So I did find a way to get to my accounts and bypass this screen, but that's just bad. That's just not ethical software design. Other principles that prime or influence what users expect. We've talked a little bit about archetypes. Let me show you an example. I was in a hotel in Pennsylvania, and I'm going to get on the internet. So, yeah, I just want free internet, do some browsing. So I see that thing, high-speed internet, and I press it. And I get nothing. Why? Because it's not a button. When I scroll down and see the whole screen, it looks like this. Don't make things in your UI that look like buttons but aren't buttons. I mean, if the elevator example didn't already convince you, I hope this does. And I see this more commonly than you would think. People put headers and they look like buttons. Don't do that. I mean, that's a button, but it looks exactly the same as that except for a little bit of margin. And yeah, we've seen that example. I meant to remove that slide from there. When you use color, you do need to be aware, though, that users don't actually see color the way you think that they do. For example, if I mask out a bunch of things here and get down to there, see, those two balls were actually the same color. It's just that your eyes aren't tuned to that because you see color in relation to other color. Let me show you my little app for that. Oops, no, it's the wrong one. Yeah, that's it. So let's take a look at this. That bar going through the middle is all the same color. It's monochrome. Your eye, however, does not perceive it that way because your eye perceives color in relation to the colors around it. That was necessary when we were out worrying about leopards and such. You want to be able to see that the leopard is a leopard, whether it's in sunshine or whether it's in shade. So your eyes are evolved to be able to automatically adjust to varying conditions and see things in relation to the other things around that thing. To show you here, I got this guy's draggable, so I can drag him. Okay, I'm just going to drag him. I'll put it in here. I'm going to drag him along the thing, and you'll see. And I promise you, I'm not changing the color of him as I move him. He's just gray. And that works in any color. Works in blue. Same story. The optical illusion that kicked a lot of this off, done by the researchers, is this one. Who's seen this? Yeah. You didn't believe it, did you? That A and B are actually the same color? Here, I'll show you. You can mask it out and do it like I did with one of the other ones, but I wrote a program to let me drag. I did a little extract of the B, so I can drag. Now, watch carefully now. There's B, there's B, there's B, there's B, until he gets into here. And then I'm going to put him here, and then when he gets to here, he just fits right in. So understand, you want to use gradients because they feel natural to the user in many cases. Pure monochrome feels artificial. But be careful about using colors that you don't get into trouble with people misinterpreting them. Okay. How much time have I got left? About 5 minutes? Something like that? Oh, no, I've got less than that, don't I? I better get going then because I've got a lot of interesting stuff I'd like to show you if I can. I'm going to skip this part then, since I'm a little bit, and get down to effective use of color. Keep your overall theme subtle, because you want things, when you do use color for signaling, you want it to stand out. Don't make things too bright, even for signaling. I never use genuine red for hardly anything. I use instead a color called light salmon, which is kind of a reddish orangish color and communicates very well but isn't so fatiguing to look at. Use subtle gradients, I mentioned that. Check your culture. In China, good is actually signaled with red. And delegate this to visual specialists when you can. They're pretty good at it. Other factors combine with color to affect meaning. For example, smoothness connotes safety. Sharp edges connote danger. That's called the contour bias principle. I can prove this to you in the following sense, that kind of information, the sharpness, etc., is more important than words in some situations. You need to be convinced. You could send this to your significant other. Isn't that a beautiful font? You'll always be my Valentine. But if you do nothing but change the shapes, now the perceived meaning is dramatically different. Yeah. Am I out of time now? I was going to talk about color blindness, but I think I'm out of time. Can somebody tip me off on that? Officially, yeah. Well, then I will officially stop because I don't like to. But it's lunchtime. It's lunchtime. Oh, do you want to stay for a few more minutes then, it being lunchtime? Okay, well, great. Then we'll do a few more minutes. Thank you for indulging me then. Anybody that leaves, I won't feel bad about it. You may be hungry at this point. Color blindness. It doesn't mean a person can't see color. It means certain pairs of colors, they find it hard to tell the difference. And it's only around 5% of the typical user population, primarily male. Red-green color blindness is the most common. If you take care of that, you're down to a small fraction of 1% of people who are going to struggle. And the most common way to deal with color blindness in your apps is to have themes. Have a colorblind theme. That's what we normally do. These days, dark theme, light theme, colorblind theme would typically be the three themes that you would want to implement. So red-green colorblind users, it's not just red-green. It's various shades of red from various shades of green. They also can't tell dark red from black very well, or blue from purple, or it turns out light green from white is a struggle. So what you do typically, if you've got something like this, and you really don't know how that's going to come across to colorblind people, there are actually apps, and you can paste a bitmap, screenshot of your app into this app, and it will show you what a colorblind person is going to perceive it. But you can do a quick and dirty way of doing that just by applying a grayscale filter. And in this case, you can see the gray kind of fades away and you don't see it anymore, whereas the orange still stands out pretty well. So it's not just color, it's also hue that matter. To accommodate colorblind people, vary by saturation and brightness as well as color, and try to lean on shapes as well as color. You don't have to just use color for signaling. Ideally, you would use shapes as well. And so that means that the colorblind folks are going to have some information to pick up on. My general principle here is you should design so that the 95% of people who aren't colorblind have a great experience and the colorblind people have a good experience. They simply can't perceive all the things you put into the app otherwise. But you want to accommodate them by taking these principles into account. As I said, there are software simulators there. But don't handicap the 95%. Do all kinds of variations. Let's talk just a bit about mental mapping, and I will let you go to lunch. I talked about it a little bit before, but it's very important, and I don't see it used as often in software as I think it should be. I'm going to illustrate by showing a couple of examples from my life of the gas range I used for 8 years back in the 80s and early 90s, and the gas range I've used for the last 26 years. The one that I used for 8 years back in the 80s, I never turned on the wrong burner. Not a single time. The one I have now, which is going to be the one there on the left, I turned on a wrong burner about 2 months ago. I do it several times a year. What's the difference between these ranges? This is what the buttons look like on the range I have today. There are labels, of course, which, of course, I don't read most of the time. This is what the knobs look like on the range I used to have, and I wish I had it back, even though it was manufactured in the 50s. Notice the perspective of the burners matches the arrangement of the knobs. That's an example of the mapping principle, mental mapping of a control surface to what's going on in the real world. Here's another one. I took this in my hotel room just down the street. You've got big flush, small flush. So what do the control things look like? They're big and they're small. It's amazing to me that most developers don't even think about making buttons different sizes to communicate something about what they do in the real world. This has no labels. Well, in a city like London with international visitors, labels would not be desirable, would not be the best way to do it. So, how would you like to look at information? Well, let's suppose we've got some, customer interaction information. There's the data grid way. There's the more modern app kind of thing you might put on your smartphone. That's not too bad, but what if we put it on a timeline that we know when the thing happened roughly by mapping on a timeline? That's another example of mental mapping. People automatically do it. We also get some leverage of the proximity principle because things that happened close together are grouped close together, and therefore they're probably related in some fashion. We're going to okay. Well, that's, fortunately, I had an example from Dropbox, but that was my last one, so I will put up my last slide, and you folks can go have some lunch.
There's another fucking 10 minutes.
Oh, there is? See, they deceived me. I said I could go on. I'm sorry. Whoever the presenter is next time, I beg your pardon. I will get out right now. Thank you very much, folks. You're welcome to come and talk to me as I share Tear Down if you wish.